Hey everyone, welcome back to DWeb Decoded, a podcast by Filecoin Foundation exploring the intersection of blockchain and the data economy. I'm your host, Aaron Stanley, and today I'm joined by Edan Yago, founder of Bitcoin OS. We're going to be talking about verifiable compute on Bitcoin, quantum computing threats, and a lot more. Yago, thanks for coming on the show.
Thanks for having me. Absolute pleasure.
So yeah, super excited for this conversation. I would love to get started by maybe having you give us the TLDR on just what you're building with Bitcoin OS, and then we'll jump into your background.
So what we're building with Boss is effectively the second half of Bitcoin, right? Letting everyone be early to Bitcoin again by building what's been missing. So Bitcoin today is by far the most widely adopted, most trusted global ledger. And it is also the home to the most important digital crypto asset, BTC. But what you can do with BTC is extremely limited. If you're like me and you've been holding BTC for a long time, basically the only thing you can do is sell it, right? You can send it to someone else in exchange for something. There are no services. There are no applications. And for the world's most trusted, most secure ledger, there's no other assets really either. And so what we're building with Boss is the ability to provide programmability, scalability, and a whole new world of applications to Bitcoin. And we're doing it in a way which I think reimagines crypto as a whole and allows the entire crypto ecosystem to deeply integrate with Bitcoin and become a single unified ecosystem.
No, I love that. And then maybe before we dive into that more specifically, maybe tell us a bit about your background. I know you've been around in Bitcoin for a long time. You've kind of done a lot of things. So maybe give us a bit of an overview of what you've been working on since you discovered Bitcoin.
Yeah, so I've been around the block. I've been building in the Bitcoin space now for 14 years. Among other things, I helped build, founded one of the first companies that was doing remittance using Bitcoin as a settlement system. We also integrated the first banks into Bitcoin. Many of the largest banks in the world were integrated using our technology. That company was called Epiphyte. One of the cool things that also happened at Epiphyte was the discovery or invention of the Lightning Network. And I then have been involved also in building out Sovereign. Sovereign was probably the pioneering project which brought DeFi to Bitcoin and is today the largest ecosystem of DeFi applications for Bitcoin. And for the last 4 years, I've been working on how we can bring ZK to Bitcoin as a way of building scalability, programmability, rollups, and integrations with other chains.
And so as you were alluding to earlier, Bitcoin has traditionally offered both there's basically been two things that Bitcoin offers. Like there's the verifiable ownership and there's verifiable transactions. So I can the blockchain will attest that I own this asset and it will attest that I've sent this asset to you. But the computation part, the verifiable computation part, or any types of other additional services beyond that has been kind of the missing piece. And that's what sort of gave rise to Ethereum and all these other chains eventually, right? Maybe talk a bit about why this has been such a difficult problem to solve, like 15 years into Bitcoin.
That's a good question. Why has it been difficult to solve, not just for Bitcoin, but for anyone? Because it's not a solved problem, right? So you look at Ethereum, you look at Solana, they haven't solved the problem. They haven't solved the problem in a lot of ways. Ethereum is fragmenting in its efforts to scale itself via rollups. It is becoming increasingly complex from a code perspective. There's no one in the world who fully understands the Ethereum code base anymore. And it, famously is struggling to scale. And Solana has, massive number of transactions, sometimes as high as 75, 85% of transactions fail. It's not able to manage the highest throughput applications. And so many other applications are being built elsewhere. Like, for example, we've recently seen the success of Hyperliquid. Didn't happen on Solana. And unfortunately, Solana also, with some frequency, will go down, right? You kind of have to reboot it. So it hasn't really been a Bitcoin problem. The main problem has been that what Bitcoiners have been saying for the last 16 years, um, from Satoshi, and people in the Ethereum ecosystem now, they have a little bit more experience with the problem, have been saying, is that you cannot scale blockchain by just building bigger and bigger machines and more complicated blockchains, right? You can't do this whole monolithic scaling. Um, it doesn't scale that way effectively, because blockchains have this really interesting property where every single transaction needs to be ordered and everyone needs to agree on that order of transaction. Blockchains, as opposed to the internet, which is sort of like built like a web of many parallel transactions, or data transactions, right? So, like, for example, right now when I'm talking to you, the data is being sent from my computer ultimately to your computer, but not the rest of the internet doesn't need to know about it, right? So other people are sending other things and we don't know about that. So it's parallelized. But in a blockchain, everything gets ordered. And so effectively, it all ends up looking like one big pipe. And there's just simply a limit to how much you can just expand the pipe. What's changed recently is that we have found ways of taking the burden off of the blockchain and having things happen in parallel environments, and then just taking a very small amount of data which proves that activity and bring it onto the chain. This is ZK technology, and it is being used in different ways. People are, for example, using it for rollups, but the basic idea is that you have this base ledger, right? And the ledger just records the end state of computation, and all of the computation itself is moved off chain. And this is the big unlock. And so what we're now seeing is that crypto is rapidly moving into a world where more and more of the activity is being done in that way. And the technologies are finally available because of, to a great extent, the work that Boss has done, the work that Bitcoin OS has done, makes that possible on Bitcoin as well. And Bitcoin is really special because Bitcoin was built with this belief and has been maintained for 16 years with this belief that if you maintain the simplicity of the ledger, you keep the ledger a pure play, highly secure, highly simple ledger, it actually becomes easier to scale once you get ZK capabilities. And so what we're doing by having computation off chain is we're basically allowing Bitcoin to become a fully scalable, fully compute ready system while maintaining the simplicity of its base ledger.
I love that. That's super interesting. So is a way to think about it in the way that Ethereum has embraced kind of the modular roll-up roadmap, where they've moved a lot of the computation, and they've moved a lot of the transactions to these layer twos, and then basically these layer twos all sort of, via ZK or via however they kind of report back the end state to the main chain. And it's kind of the similar idea, but it's not. But we're not necessarily. You're not building a layer two though. That's kind of the main thing.
So it is a similar idea, but you're right. It's sort of the way that it's been done in Ethereum is people sort of said, okay, well, people like blockchains, so let's put a blockchain on your blockchain, right? Each rollup is another blockchain sitting on the Ethereum blockchain. And I think that happened because people started thinking in terms of blockchains as being like the center of our industry, which they really aren't. They never have been, right? People are interested in transactions and assets, not in chains. And people have forgotten that chains really only exist to create a ledger. But because paradigmatically, the way Ethereum had to be built when it was you shoved everything into the chain. And as a result, paradigmatically, and paradoxically, when Ethereum needed to scale, they basically created a whole new chain Arbitrum a whole new chain, OP-Stack a whole new chain, and then OP-Stack sort of broke up into a whole bunch of other chains, and so now you've got chains on top of chains on top of chains. What we're doing differently, and what I think Bitcoin is doing differently, is pushing that idea to using first principles to its limit, right? Why would you want to roll up a chain when what you really want to be doing is rolling up a transaction or a set of transactions or an application? And so while there are projects that are building sort of chains that will roll up to Bitcoin using Boss, I think the most exciting thing that we're doing is we actually allow people to use the Bitcoin ledger as a general purpose, programmable ledger itself. Issue any token that you want, real world assets, stable coins, DAO assets on Bitcoin. Have whatever level of sort of application sophistication and complexity you want, right? Like smart contracts. But those smart contracts don't need to live on Bitcoin. They can live elsewhere. And you can do the computation, and you can then verify that computation on Bitcoin with these tiny, tiny little proofs that are much smaller than even a standard Bitcoin transaction.
So then maybe talk about what does it mean just practically to think of Bitcoin as an operating system, like the way that you guys are kind of envisioning it here. Like what other types of, I guess things can be, what other types of things can be done in this context if this off-chain compute is like literally brought to Bitcoin? Like what and maybe even as a corollary to that, like what does this mean for other chains just in crypto generally? Like I've seen there's been a few folks that have been other like Cardano and some other folks that have been integrating with you guys or in the process of trying to integrate or do it, and like how does that I guess how does this kind of enlarge the whole pie maybe?
I think one of the things that we've seen in crypto is this narrative, this dominance of having to come up with new narratives. And there's sort of like some big themes out there that we've been sort of talking about and promising the world, promising ourselves for a long time. One of those is this idea of Web3, or the idea of the internet of value, that we were going to rebuild the entire internet. And I think that doesn't really make sense. The internet already works. It's well established. It's got significant network effects. We're not going to be able to replace it, right? There's not going to be another chain which suddenly becomes the internet of the future. Rather, what we need is the internet with value, right? So what is the big thing missing in the internet? The big thing missing in the internet is the ability to have property rights, is the ability to have assets, is the ability to actually own anything, right? And so I think the way that we should be thinking about this is Bitcoin through Boss becomes another pillar of the internet. It becomes the ledger for the internet. It becomes where the internet writes ownership, transacts ownership, manages ownership. And then the rest of the internet can integrate with that. And so a computer game can issue assets which get written to Bitcoin, transacted ultimately on Bitcoin. A social media platform can give you the right to control your data and give you ownership of your data, but not as a new chain or as a separate platform, rather as a Web 2, a platform built like Web 2 in whatever language people want to build, TypeScript, Rust, C++, right? And then take that entire system, prove it, right? Run it on different servers, right? Not on a blockchain. Run it on servers just like they would run any Web 2 application, but prove that what is being run is correct, right? Make that system incorruptible and prove and execute and enforce that incorruptibility on Bitcoin. And so what Bitcoin becomes is the ultimate system, the ultimate guardian of the internet against the corruption of systems, and the protection and system which allows people to own and transact assets that actually exist on separate systems in the internet. So let's bring this down to earth. Right now, Visa and the banks and Stripe and basically everyone is talking about stablecoins.
Right.
And you could imagine a scenario where everyone, Visa go and create their own chain, and somebody's trying to put stablecoins across all kinds of different chains, and the whole thing becomes extremely messy, and currently is. And so what you would actually want is you would want a settlement mechanism so that these different stablecoins can be transacted for each other, especially as we go from having two main stablecoins to potentially tens or hundreds of significant stablecoins. You want different payment mechanisms to be able to talk to each other. You want this to be able to happen seamlessly and with a unified settlement mechanism. And Bitcoin is perfectly placed to play that role. So how does Cardano, like one of the questions you asked is like, how does Cardano play into this? Well, in the same way that we don't want to rebuild the internet, we also don't want to rebuild crypto. A huge amount of infrastructure has been built in crypto. But today, crypto feels, because it is, like an extremely fragmented ecosystem, almost like a whole bunch of islands. Each island has its own casino on it. And then if you want to go from one island to another, you use these bridges, which are like these rowboats that you and all of your money get into this rowboat, and you have to get past sharks and pirates from North Korea.
North Koreans. Yeah.
Right. So what Cardano have realized is that they can integrate into this massive asset base and this massive trusted ledger, and the infrastructure that they've built out for smart contracts, for building applications, for letting developers build different systems, can then actually run on Cardano but execute on Bitcoin. And not only that, when Litecoin are doing the same thing, integrate into Bitcoin, and Sway integrate into Bitcoin, and Ethereum integrates into Bitcoin, all of these different systems effectively become integrated into the same settlement mechanism. And so the vision here, and I think what we're a few years away from being able to demonstrate, is that the era of blockchains will be over. We will instead have the era of assets, right? We won't be the blockchain industry, which no one wants. Will be the asset and ownership industry. And the differences between Web 2 blockchains and Bitcoin will dissolve as they effectively become a single unified system, with Web 2 systems utilizing smart contracts on different chains based on their needs and settling their transactions on Bitcoin.
I love that. That's a good corollary to my next question was going to be like why Bitcoin is perhaps like uniquely positioned to play this role, which you've kind of addressed that vis-a-vis Ethereum or Solana. But I guess the other question would be, maybe help me understand like why Bitcoin would be like, assume we're talking about just today, right? Like why would Bitcoin be a better place to run my compute job or like tokenize my asset than like Ethereum or Solana? So if I wanted to tokenize my house or something, like what would be the advantage of putting this on Bitcoin versus on Ethereum or Solana or one of these other networks?
Well, you spoke about two different things. One is running a compute job and one is tokenizing your house. I'll start with tokenizing your house, right? Which is not a computationally intense task. What it really is a task focused on property rights. Now, property rights are based on one fundamental thing, which is reliability. A house is something which is going to last generations. So if you are now going to want to be able to provide a canonical digital token representing the ownership of that house and the rights attached to the ownership of that house, where are you going to put it? Are you going to put it on a system where that system changes forks, right? Has hard forks every few months. And so therefore your token, and frequently these are not backwards compatible. Basically, are you going to put it on a system where you need for the next several generations to maintain that? and where there's even a question about whether or not that system will exist in its form or any form in the future, or you're going to put it in somewhere where the system that exists today is like the system that will exist in 100 years, and which also the rest of the world already trusts and is integrating with. So one of the big mysteries of crypto is we've built so much. We've built the ability to issue assets, the ability to transact in assets borderlessly. We've built additional scale. We've built DeFi. We've built all of this stuff. And yet, the vast majority of crypto remains sort of somewhere between Ponzi to casino to speculation. And everyone knows this. We all talk about it all the time, but almost never do you hear people ask the question of why. Why is this the case? And I actually have an answer, which I think is pretty simple. And it's that form follows function. The kinds of things that you will build on a platform depend on what the platform allows you to do. And what platforms like Solana and Ethereum allow you to do very well is innovate and experiment and do things where your time horizon is short, because these are time horizon short systems, right? They basically are built like software which is constantly changing and upgrading. Whereas Bitcoin is built like permaware. It is unchanging, right? It is much more like a law of nature, which really no one controls. And so when you have a platform that is ephemeral or ethereal, right, then the products that will be built on it by the products that we will build on it are also, as a result, going to be ephemeral and ethereal. You cannot build savings accounts for the masses on Ethereum. You cannot do retirement accounts on Ethereum. You cannot do long-term finance on Ethereum. You cannot do bond issuance on Ethereum, where people need to be able to trust that bond issuance regardless of who issued it, right? Because Ethereum itself is just too unstable. And the reality is that 99% of all finance is long-term finance. Think about what people do with their money. It's mortgages and savings accounts and pensions and inheritance. That's where 99% of the retail money is. And institutional money is long-term bonds. It's equity holdings. It's infrastructure projects with 30-year paybacks. It's, everything is multi-decade, multi-generation. And so because we haven't been we haven't had a platform that allows you to build systems which can be reliable for decades, we haven't built anything which is in that 99% of real finance. So what happens now is that if we unlock Bitcoin and we finally get a ledger that people can trust for decades or generations, we open the door to bringing on all of those use cases that we've spoken about and sort of imagined and dreamed about, but have never materialized because we never had the appropriate infrastructure.
So what does all this mean for Bitcoin block space demand and activity moving ahead? Because I know that this is an issue that a lot of people kind of get worried about when we start thinking about miner fees in 100 years time or whatever. Are the fees going to be enough to incentivize the miners to keep the chain, maintain the chain, et cetera? But like, does this idea, this what you're proposing here, does this sort of eliminate this issue of like, what's going to fill the blocks? Like, what's the incentive to keep these blocks, keep putting transactions in these blocks?
I think what's going to happen is that Bitcoin block space, which is extremely limited, it's 4 megabytes of space globally every 10 minutes. It's nothing, right? So I think what we're going to see is that's going to become the most valuable digital real estate in the world. It's going to become increasingly expensive and difficult to use for anyone. And everyone, including people like me who have been, transacting on the Bitcoin chain for well over a decade now, are going to find that we're not transacting on Bitcoin mainnet. Bitcoin is going to become a public utility, a settlement mechanism for the world. It is the global settlement mechanism. And as a result, you will transact on whatever application or service that you're using, and those services between themselves will settle via Bitcoin. So Bitcoin is going to become like like the internet itself, right? When you're transacting or interacting with the internet, you don't plug yourself directly into the internet. No one does that anymore. You talk to your ISP or your service provider, and the ISPs are connected to the internet, and they communicate between themselves over the backbone of the internet, not you. But from your perspective, it doesn't matter. The experience and effectively the censorship resistance is the same. You can communicate with me and our messages are shared over the backbone of the internet, but as the internet acting as a global settlement mechanism. So Bitcoin is the largest piece of public digital infrastructure that we have outside of the internet itself, and it is rapidly now going to be merging with the internet and effectively becoming the second shoe of the internet. Right? We had the data side, and now we will have the permanence or asset side.
So how do you see this converging with some of these DePIN networks that we've seen emerging the last couple of years, whether they be like decentralized data storage type networks or these decentralized GPU compute marketplaces? Do you see like these types of protocols perhaps like kind of settling to Bitcoin at the end of the day? Like Bitcoin becomes kind of the permanent ledger of truth that these types of protocols all like revert back to. Like I could do my compute job using one of these decentralized GPU marketplaces, and that sort of attests to the Bitcoin blockchain, just proving that this compute job happened, et cetera. But I'm using these other protocols. Maybe kind of riff a bit about that, but like how all these things might fit together.
Yeah, I think that's exactly what we're moving towards there. Like let's take Filecoin for example, right? Filecoin specializes in providing a layer to the internet, which I think is going to become increasingly important, of reliable and censorship-resistant data storage. Bitcoin is not designed to do that at all, right? Remember, 4 megabytes of space every 10 minutes. So other systems, and this is sort of where Cardano plays a role, Ethereum plays a role, Filecoin play a role. Other systems, by plugging into Bitcoin, which plugs into the internet, can augment the internet and as a result, Web 2 services directly. And then the role that Bitcoin plays here is in providing you with the proof of reliability. So if I am storing valuable information, and this could be valuable information because it's like, the heart, the core information for my company, or it could be, a poem that my wife wrote to me before we got married. Different kinds of valuable information. But I want to make sure that is never lost. That can be stored on Filecoin, and the fact that that people are committed to continue to store it can be attested to on Bitcoin. And my payment to make sure that is always incentivized can happen through Bitcoin, right? And so Bitcoin provides the payment attestation. Bitcoin provides the rights management. It's basically a rights management system, right? And then these other services, which could get very, very large as Bitcoin becomes deeper and more deeply integrated with the internet, these other systems, they augment it with specific applications or services that are required.
Amazing. No, thank you. That's super interesting. I could definitely see a lot of interesting use cases there. I want to kind of switch gears here slightly and talk a bit about quantum computing. So we actually did a panel about this at Davos, and I've really enjoyed your insights. Found it really, really helpful. Kind of understanding some of the current state of this trend. I think back in January, there was kind of a wave of like quantum computing doomerism going around that people were kind of freaking out about. So it was interesting to have some of these conversations. But I mean, we've seen a lot of developments around this topic this past year, both in terms of like new products and chips being released by Google and Microsoft and others, and where there's governments announcing strategic quantum like investment funds and all these kind of things. And I was hoping you could maybe just tell us a bit from like your vantage point, like the state of kind of quantum computing vis-a-vis maybe some of the hype and the fear around it right now.
Well, I think quantum computing is a very real risk to any form of cryptography, certainly to forms of cryptography that haven't been hardened against quantum computing, which is basically almost all the cryptography that we use right now across the crypto space. And specifically for Bitcoin, I think Bitcoin seems pretty unstoppable, with the exception of this. I think quantum computing is the one very, very clear existential risk to Bitcoin if nothing is done. Thankfully, I think the chance that nothing will be done is basically zero. There's too much value at stake, and the solutions are already being developed. So how close is this threat of quantum computing? And maybe a quick word on why quantum computing is a threat. All of crypto is basically based on this idea that we have these passphrases. What is your public-private key? It's this very, very long, random-looking a set of characters, right? And unless someone can guess what that exact set of characters are, they cannot gain access to your funds. But you know what they are, and so there's this asymmetry between those who own the key and those who don't, which is extremely powerful. The way you can try and break this, if you have a very, very short password, is you brute force it, right? You try lots of different combinations. Doing that with a regular computer at the scale of the size of the keys or the size of the cryptography that we're using today is an impossible task. But quantum computing changes that, because the way quantum computing works is I think it's not an exaggeration to say, effectively borrows compute from parallel universes, right? So what is quantum computing? It's you have, instead of a bit, right, which is 0 or 1, you have a bit which is probabilistically 0 or 1, and we call that a qubit. And the reason we call it a qubit is because it's computing in the quantum realm. What is the quantum realm? Well, we don't exactly know, but it can be accurately described as parallel universes of probability. And so what quantum computing is magic. It's magic. We're reaching into parallel universes and we're pulling out their compute power, which means that instead of brute forcing with a single computer, you're brute forcing with an infinite number of computers.
Oh, wow.
And so if you are able to build a computer which is able to brute force each character, right, then suddenly things which were impossible to brute force become easy or trivial to brute force. And so there are algorithms which behave differently. They're not amenable to quantum types of computers, which can be more secure. And we're going to have to see all of crypto, not just Bitcoin, transition to them over the next few years.
Interesting. So basically, like the elliptic curve used in these the cryptography underlying Bitcoin, like basically this can be just brute force broken open by this infinite computing power, essentially. Like if you're just doing kind of like just guessing and checking, like if you just have one machine or a handful of machines, it's basically impossible.
So it wouldn't look like guessing and checking, because your computer would just like run a program and tell you what the answer is. But effectively, it would be guessing and checking across all of these infinite parallel universes. Yes.
Wow. Okay. Okay. So, and I've heard you mention before that while these qubits, like these quantum bits, while they basically, like individually they can become, they're quite powerful, but they kind of become like less effective when there's more of them involved in a particular job. And
Yes.
and that this
Yes.
and that this was sort of your rationale for saying like you don't necessarily think that this quantum revolution is maybe like as close as some people say, because this poses a pretty significant adoption or barrier to adoption and scaling. And hoping you can maybe hopefully I'm assuming I understood you correctly, but maybe correct me if I'm wrong, but like maybe explain more about what you mean by that.
It's a very, very difficult problem, right? So, like I say, this is magic. Okay. And if you actually look at quantum computers, they look like alien devices from, some kind of, I mean, they're cathedrals of alienness. But each qubit itself is it's like a glitch in the matrix, right? and because it's a glitch in the matrix, it's extremely unstable. And what's worse is that as you add more of these glitches in the matrix, that they start glitching out each other. And so this process is called decoherence, right? And so having a single coherent qubit we can do. But when you start adding 2 or 3, they decohere each other. So there's 2 solutions to this. One is sort of like building hardware which reduce the decoherence, and the other is building algorithms which compensate for the decoherence. So you have what are called logical qubits, which are actually multiple different qubits, but they act as one because you sort of average them out so that their decoherence becomes less important. The bottom line is this is a very, very difficult problem. Right? Reaching out into parallel universes and using their computers is a hard problem. But it seems increasingly like it is solvable, or actually I should say it has been solved. It has been done. We've done it. We just haven't done it on a big scale. And it seems like the problem of being able to add more and more qubits and keep them stable enough to actually compute on them is being solved. And the progress seems to be starting to get quite rapid. So I don't think we're looking at significant quantum computers probably for the next 5 years, but 5 years is a little over 1 Bitcoin cycle.
Yeah, yeah, exactly. And then I mean maybe let's kind of tie this back into the Bitcoin OS conversation, but like maybe is there anything that you guys are doing in particular kind of that you're building out or like forecasting out, like with the expectation that, hey, this is going to become a problem, like this is going to be something that we'll need to address or we'll need to kind of incorporate somehow, or, I mean, and then I'd also be interested in talking in learning a bit more about like, what are some of the things being done by the Bitcoin community to sort of, prevent this from just, destroying this whole system essentially.
So first of all, I'll start with BOSS. We are using some cryptography which is quantum secure, but we're using enough cryptography which is not quantum secure that I would say that in a quantum world, BOSS as it exists today would be an insecure system. And so we ourselves need to evolve towards this, and that is not trivial because there's a big price that you pay for using quantum secure systems. They're more expensive computationally, and so we would become less efficient in today's world. But we are prepared. We have a plan for transitioning to a quantum secure environment, a quantum secure world. Bitcoin is also developing various plans for a post-quantum world. There's some pretty good proposals already on the table. But I think the main thing is that right now, more and more attention needs to be ramping up. We've been in the Bitcoin ecosystem talking about a lot of things, OPCTV, OPCAT, OP, all kinds of other stuff, which in comparison to the importance of being able to make Bitcoin post-quantum secure, quite pale in importance. And so I think there's now a process that needs to happen and is starting of galvanizing minds around this problem.
That's encouraging to hear. No, this is a super interesting topic that I'll confess I'm not quite knowledgeable enough about to ask any like super like deep questions.
I'm not an expert either, but I've managed to. Yeah.
But yeah, it's interesting to hear that because like you mentioned, this is kind of like it's almost like the final like FUD boss of Bitcoin, right? Like we've kind of if you kind of look at the sequence of different, whether it's like ESG, like Bitcoin's destroying the environment, or like Bitcoin's only used for money
It
laundering.
all seems so trivial now, right?
Yeah, and it's like now it's like okay, now there's like a real like this the real final boss, right? Here you have to overcome. But yeah, maybe we'll wrap it up here. We're hitting time, but Yago, really appreciate you coming on the show and talking about this. It's super interesting, and it's really exciting to see just kind of the vision that you have for this, and I love just how I feel like this is what you guys are building is something that has the potential to really just kind of grow the pie massively, right? And avoid this kind of I like this island analogy used earlier, where crypto is just kind of this like weird little sea of islands that everyone has to kind of paddle around and try to, but
merge
I think
the islands into a giant continent.
Yeah, exactly.
A new land where we can achieve levels of prosperity and grow an entire new economy.
I love that. Well, maybe I'll turn it back to you for any like quick like final thoughts, and then how can folks find you or learn more about Boss?
Yeah, I think to summarize, we are at an extremely exciting point in time. Bitcoin is quite obviously sort of winning on an accelerated pace. We're starting to see stable coins following in Bitcoin's wake, and we're seeing these systems now begin to be integrated. With Bitcoin now having, because of technologies that we're building at Boss and additional technologies being built on Bitcoin, the ability to scale, to act as a settlement mechanism, a general purpose ledger, and to allow the rest of crypto to integrate into Bitcoin. I think we are at a turning point for the entire crypto space, right? This is going to be the future of property rights, of transactions. And our mission is to build it as a unified system, which will have the scale and the lack of friction to actually build not an internet of value, but an internet with value. And if people are interested in this mission, it's real, it's happening. And if you want to follow along, you can follow me on Twitter. I'm at Edan Yago. You can follow Bitcoin OS, and I'd encourage you to do so. That's BTC_OS. And you can also check out the Bitcoin OS website, which is bitcoinos.build.
Awesome. Well, Yago, really appreciate your time here today. Thanks for coming on the show, and thanks everyone for watching. We'll see you next time on DWeb Decoded.
All right, fantastic. Thank you very much.